Welcome back. After talking about the different landforms, fluvial landforms, now we will look at a few terminologies which are been used for the drainage which we see on the surface. So, mostly what we will come across, because there is a very simple fundamental that if you are having a slope in any terrain and if you are having a precipitation, then you will be bound to see the formation of drainage. So, if you are having a slope in this direction, as it has been shown in this figure also, so you will see the development of the drainage. Now, what are the terms which are being used for such drainage, that we will quickly look at, and that you will be using when you are identifying the different terrain and also the different drainages. Okay. So, these are termed as also termed as the parallel drainage, but in general they are termed as consequent streams. Okay. So, stream follows the slope developed of development of slope may be due to sudden tectonic uplift, because the natural slopes are not usually seen, because the slopes are seen because of the tectonic deformation mostly. And then we have so these are termed as consequent streams, and subsequent streams are not exactly following this slope, they are developed. So, this is what has been shown here, that they are almost right angle to the original slope of the land. Okay. So, the slope we see here is, this is the topography we are having. So, slope is in this direction we are having, because this is unfolded terrain, and then we are having the slope here, this is a valley here. Okay. But if there is an erosion which is taking place here, so this is almost right angle to the slope. So, those such streams are termed as subsequent streams. Then if the stream is crossing the folded areas, okay, then they are termed as antecedent streams. And then there is another one which is what we call the superposed streams, which are incising the inclined surface, and then which has been covered later on by the flat depositional stratum, which has been made because of the deposition. So, if it is incising that, then we term this as an superposed streams or drainage. Stream piracy again is a common process which one can come across in any area, and this is basically because of the headward erosion of the drainage evolution. So, time will come when this one of the drainage basin will breach the divide, and you will see that it has been the whole drainage has been taken up by one of the drainage system. Okay. And that is what we call stream piracy. Now, coming to the drainage pattern, the geometry of the stream network in a region that reflects aspects of underlying geology. So, as I told that there is a difference between the drainage pattern and the channel pattern. So, this you should keep in mind, and till now you must have understood that the drainage pattern we will just see, but the channel pattern mainly are the straight, meander and braided one. Now, while I will show couple of examples from the Himalayan region, and then we will move to the general part of that, what are the different type of drainage pattern and what exactly it talks about the subsurface one. So, if you look at this one, this is a shaded relief map of, and this exercise again you are going to do in your labs. So, this is the area of northwest Himalaya, and we So, this you must be aware about this town Ropar and Hoshiarpur. So, and this one is your Kangra valley here, it goes to the Kangra valley is here. So, and this is the town Kangra and Dharamshala. So, if you carefully look at the overall landscape, then you will be able to see that there is a divide here in the frontal part of the Himalayas, and then you are having the drainages which are flowing in either direction. So, this is the drainage divide. So, you will be able to pick up the drainage very easily from the digital elevation model. This is again another example that you can use the data, satellite data, to generate a 3D perspective view of the terrain, and you can rotate it or put it at different angle as you wish to view the terrain in best way. Now, coming to this part, again this we will be talking about in the labs, that how to extract the drainage, but as what I was showing here is the same area, and this is the part where I was talking about the drainage divide. Okay. So, you can clearly demarcate the drainage divide, and this is based on what we have been talking about, that one of the drainage is flowing in one direction on this direction and another one is in different direction. This portion is again in flat area on the top, where you are having the drainage which is flowing away from here, and this is in this direction, and the darker one is the major trunk stream. Okay. So, you can also talk about the order of streams here based on the extraction which we have done of the drainage. So, this you will be doing in one of your lab exercise. Okay. So, order, what we see is the darker lines, darker streams or thicker one are the higher order streams. Okay. And that is the trunk streams, and what you see here, this one where I am putting the cursor, and this one is your Bias river, and this one is your Satluj. So, most common drainage pattern which one can come across in the areas are the dendritic, which will be like if you are having a tree and then you are having the tree stems which are growing, it is typically like that. Okay. So, you will see in the dendritic pattern, then you have a radial pattern which again indicates about the landform, and then you are having a trellis pattern. Trellis pattern is mostly seen in the folded terrains. So, you are having the harder rocks and softer rock combination, and mostly what has been seen here, that the trunk stream is crossing this area, and the tributaries will be almost at the right angle. So, you are having the softer and harder rocks. So, you will have the resistance rocks are this one, which are marked by darker color, and then less resistance rocks will allow the formation of the small lower order streams, and that will be almost at right angle unless you see in folded terrain. And then you are having in the, if you are having fractures in the terrain, then you can come across this type of rectangular drainage that will be almost at the right angle to that. Okay. So, investigation along the Son Dune, what we did was that this was the area which we were looking at, and we prepared a detailed map, and that what you are going to, this is the image, and what right now I am showing is in Landsat image and false color composite. So, what we usually expect you to do is that you prepare such type of geomorphic map. So, what we have in this map is basically all the drainage has been marked here, and then you are having the terraces which have been marked in different color, which have been named here as QT0, then Q T1, T2 and T3 and so on. So, these are the different terraces which are been seen here, and then along with that we have also marked the faults, active faults here. Okay. So, this part we will try to cover if possible. If you are having enough time left out with us, then we will try to teach how, what are this landforms, and what is the importance of this in terms of the earthquake hazard. But right now what I would like to show you is that there was an area which was we never expected that this type of feature will come across, but based on the drainage we were able to judge that what exactly this area is showing, and then we checked in the field also. Okay. So, if I would say that if you carefully look at this area particularly, then what you can make out is that there is a stream which is flowing here in this direction, and there is a stream, another stream which is flowing, or many streams which are flowing in like that. Okay. So, you have sort of an domal structure. So, this is a center here, and the drainage is moving away from this. Okay. So, it is quite possible that this is an elevated portion, and then you are having a slope on either side. Okay, as what we were looking in the radial drainage. Okay. So, this is typical of the radial drainage. So, when we looked at here in this area, this is a close up view of that. So, this you can see, this one is the close up view. So, if you carefully see that what I was showing here, that you have streams which are flowing like that. Okay, over here, and then some few streams are going like that. Okay, and then over here like this here, and then this stream is coming out here like this. Okay. So, this is the elevated portion what we can see here, because this drainage is going away from the center. So, this is typical of the domal area. So, dome is something like, if I put in cross section, then it will look something like this. Okay. So, it is having a slope on either side. So, now look at let us look at the what we see in the in field actually. So, this is the village known as Dhana, and this is not very far from Nalagarh. So, what we inferred that there is an sort of a fault here, and this area has been warping, because in the folded terrains mostly what we see is that there is the displacement which is taking place, and this can result into a sort of formation of a domal structure or a folding here. Okay. This I am putting in section here. So, this is a top surface. So, this is exactly what we inferred. Okay. And there is another fault which goes here, which has given rise to a different pattern of channels here. So, first look at this one here. What we see is that because of this blocking of resulted because of the fault, not exactly blocking, but there is because of the deformation here in this area. So, if I put in cross section, this will be seen something like this. Okay. So, you have a sort of an uplift here. So, on this surface what has happened, and then further below what we see, okay, in terms of the drainage here and over here. Okay. So, this is a close up here of this, and if I carefully mark the stream here, all the streams, then you will come across that this area is showing, it is coming like this. Okay. We are having meander here, and then going like this, and then coming out like that. Okay. Again here you have the meander, and this is what we are talking about, the tight meander in this area. Okay. And then it becomes almost straight. So, the sinuosity decreases below this line. Okay. And This is the uplifted area. So, if as I was talking about that, this is what we have. So, this portion is showing tight meander, and this is showing like the sinuosity reduces. So, this is typical of a tectonic landform. I am removing the line so that you can see it clearly what I was talking about. Okay. So, this is the line here which is responsible for the change in the channel pattern. So, such change in the channel pattern are also been taken into consideration, and sometime it could be related to the tectonic deformation. Then coming to another part here, this is what we were talking about, the based on the drainage pattern is the dhana. This is a close up of that. Again I am showing that this you can see now very clearly that what we are talking about, the tight meander. So, this is the portion in overall all the drainages which are showing tight meander. Now, dhana area, when we looked at in the field, it was very clear that the topography is something like this. Okay. So, it was this is because of the domal effect. So, this is the area dhana, and this one is here Batyan, which is on the low lying area, but this is because of the drainage which we saw a sort of a radial drainage. It was because of the typical domal topography in this region. So, based on the drainage pattern, one can interpret what exactly the lithology is subsurface, and second is the structure, that is the geological structures. Okay. So, these are the typical drainages which have been observed. Okay. This is what we were talking about when we are talking about the consequent streams, that we can also term this as in parallel streams, and this we have recently we have seen that this is a radial drainage, and so you will have like dendritic, parallel, trellis, radial, centrifugal, then and so on. You will be looking at many such patterns. Okay. So, few of them are been listed here, that from the type, that is your dendritic right up to the annular, and that description is also given here, then how it looks like. Okay. So, as I was talking about is a trellis, it looks like a tree. Then what will be the geological significance? Okay. So, then there is an homogeneous material and crystalline rocks, horizontal beds, generally regional slope, and then if you are having subdendritic, then you are having minor structural control, that is your tectonic or we can say the geological structures. Then pinnate type is like you have fine grained material, then rectangular streams you are having the area is jointed or fractured. Okay. Then you are having, for example, if you are taking parallel, then you are having steep slopes that you will also see, and then if you are looking at the radial one, then you can say that it is flowing through the folded sedimentary terrain or meta sedimentary rocks. And then you are having radial, then you are having like domes or and residual erosional features will be there. Then you are having, for example, annular, then you can structural dome. Okay. So, these are the interpretations you can make out after identifying the different drainage patterns. So, this exercise also you can do, and as I told that we will teach you earlier, we used to extract the drainage based on the satellite photographs or the satellite data. You used to draw with hand, but now you are having the softwares which can extract the drainage easily. Okay. So, dendritic pattern, as we have talked about, that most commonly we will see this drainages, and what are the information you can deduce from this. Okay. So, I have already discussed this part in the previous slide. So, I will just skip this, but you can go through and try to understand and recall when you are extracting the information from the satellite data. So, the dendritic parallel, then you are having the radial one. So, as we told that it is could be related to the higher topography, and then you are having rectangular if you are having jointed and fractured terrain. Then trellis mostly in the folded areas where you are having weak and resistive rocks. Annular again you are having in concentric path which will be seen, and this could be because of the domal or basin effect. Okay. Now, quantifying the stream network, basically the stream order in a basin can be ranked using one of the several schemes. So, we are having two, one is having Chivry and another one is stellar. So, mostly we try to use the stellar one. So, that the difference here is what we initially discussed is that in this case in Chivry, that what we have is you are having the first order to first order which will make the second order, and even if the lower order stream is joining, this will become third order. But in case of, so this will become third order here. So, two second like second order plus even first order is joining, then it will make it higher orders, and that will tremendously increase the number here. Okay. Like it can go up very high. So, to avoid that, what is there in the stellar one, that you are having two first order streams. Okay. So, 1 plus 1 will be 2 here second order, and even if the first order is joining here, this remains the second order. Only when 2 plus 2 or 3 plus 3 or any will be there, or even 1 as we talked about 1 plus 1, then it will go into 2. In this case 2 plus 2 then joining, then we will see third order, and if 3 and 3, then we will see higher order, and that what you can make out here. Okay. So, how this became fourth order? This is based on this one here. Okay. So, you are having third order, two third order streams joining here. So, this becomes your fourth order, and that is how one can classify. And as I told that earlier, we used to trace out all this, demarcate the first order, second order, and based on that we used to come up with the final order basin. And here it is, you can see that in here in this 4 and this place it is coming to 18. So, this one is more advisable. Okay. So, this is mostly been used. So, having the fourth order basin here. So, now, so earlier as I told that we used to trace all these streams and then come up with the basin, final basin, the main basin what we are looking for, and then we can also use this information for the bifurcation, obtaining bifurcation ratios. Okay. But now you can do this very quickly using the software. You can extract this drainages using DEM, and then you can also go for the stream orders. Okay. So, you can do that very quickly using the software. So, this part we initially have discussed that this is what we see in a stream order here, and then we count the number of streams, how many number of streams we see of the first order, how many of the second order, and so on. Okay. So, based on this will help in calculating the bifurcation ratio. So, when we are looking at suppose this is the part which are with us, then the bifurcation is been represented by a simple equation here, that you are this is RB is bifurcation ratio, and you are having Nu plus the divided by the next higher order streams. Okay. And that will give you the ratio here. So, number of the segments here. So, for example, you are having here. So, you can also use that, and this is what as per the Hutton law, but we can use that what we have discussed in the previous slide. So, Now, if you are looking at the first order, then how many streams we are having? This we say 10. Okay. So, this is 1 here, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, we are having 10 here, and then 2 second order is on 3 we see here 1, 2 and this is 3 here, and third order is your final stream. Okay. So, the first we will not get, but the ratio we will get from the second one. So, this ratio is 3.3 and then the ratio between the second and third order is around 3. Now, what is the importance of this? Because usually this has been used by the hydrologist or to have the understanding of the flood intensity. Okay. So, the flood intensity is considered to be a discharge along a channel over a time. Okay. Flood intensity will be influenced by rate of runoff, that is how much amount of water is been just moving without infiltration, the channel pattern, shape and number of tributaries. That will also be important, because these are the collecting streams which are going to pour water into the mainstream, and then distance downstream also. Okay. So, for example, if you are having streams coming here, and so this is your merging point, and then how much is at the downstream. Okay. What is the distance from here? So, that will also play an important part. Okay, from any drainage basin. Okay. So, from here this is like we have the collecting point here. So, what will be the discharge which we are expecting here at this point. Okay. So, these are the factors which will be affecting the flood intensity and all that. So, in stream orders, the smallest tributaries are designated as we have discussed first order. Those with the first order tributaries joins are second order, and so on. This is what we have already discussed in the previous 2 slides. Okay. So, lower order streams have shorter lag time, okay, between the rainfall. So, the lag time is between the rainfall and the flood events, okay, and are more prone to flooding. Okay. So, lower order streams, what we are talking about is if you are having many first order streams, okay, then that area is not at all good. Okay. So, that will have a shorter lag time. So, this you should keep in mind, okay, when you are talking about higher order streams with many tributaries are less prone to flooding, because that will have a higher lag time. So, this part you can keep in mind when you are talking about that. Okay. So, drainage network of a river basin, shape and channel pattern are the most vital morphometrical factors that play significant role in increasing rate of flow through the drainage system. Now, even with the higher RB values, that is a bifurcation ratio values, in elongated basin, the hydrograph is very smooth, suggesting less discharge. Okay. So, this is what you see is the less discharge, even if you are having the higher bifurcation ratios. Higher bifurcation ratios means you will have. So, there is the rounded basin with same area. This I will just show the figure here, so that you can understand this one. So, we are talking about we are taking 2 different scenarios. One is the elongated basin, another is the rounded basin. Okay. So, the aim is that to know that what will be the discharge here in this case, and what will be the discharge here. As we have been talking about, the shape of the basin will also play an important role, and of course, along with that the bifurcation ratio is also important. Okay. But higher the bifurcation ratios, you are expecting that the flooding will be very quick. Okay. But in this case, what we see here is that the shape should also be taken into consideration. Okay. So this is the discharge, there is a time here. So if you look at for this one, the hydrograph is gentle here, but in this case, okay, you are having a rounded basin, the hydrograph is quite quick. Okay. So these are the cases which have been talked here, that we are talking here is like you have an elongated basin. So this one is your elongated basin and this one is your rounded basin. Okay. So higher RB values in elongated basin, the hydrograph is very smooth, suggesting less discharge. Okay. So this is less discharge. A rounded basin with same basin area. So area is same. Okay. The basin area is same. Usually if you will just look at the basin area and you can judge that what will be the discharge, but you need to look at the shape also. Okay. So rounded basin with the same basin area having low bifurcation ratios shows higher drain discharge. So this is a bit like something unusual. What is the reason for that? That the smoother curve of the narrow basin, this is your narrow basin here. So if the smoother curve of the narrow basin with higher bifurcation ratio can be explained by greater time lag. So time which has been taken to travel, so distance is also important. Okay. So which is time taken to have a full amount of discharge here is comparatively more than compared to the rounded one. Okay. So it can be explained by the greater time lag for the water to reach the outlet, whereas the time taken from the upper ridges, middle and lower ridges in the rounded basin is less causing higher discharge. So even though the basin area is same, the discharge varies because of its shape. So this important point here is that you need to consider the shape of the basin also. Okay. The stream order and flood crust, that is your hydrograph, what we have seen here, that there is a discharge and time here. Okay. So whether it is like this or like this, or it is like smooth and very okay. So what is the importance of this hydrograph and the stream orders and all that we have discussed briefly ahead. The lower order stream tends to respond rapidly to any, like even if it is a stormy condition or it is a cloud burst and all that, with steep hydrograph. So it will be very quick. Okay. And because water has to travel a very short distance. So this is a lower order streams will not have a larger distance to be covered. So what has been shown here, the lower order streams. Okay. Hence such streams provide less time for flood warning for the downstream resident, because they have smaller drainage basin and carrying coarser and larger sediments for the given area. Okay. Whereas the higher order streams with numerous tributaries have longer lag time between the storm and the downstream flood. Okay. Their hydrograph are less peaked. Okay. So it will be like in this case it will be like something like this. Okay. But in this case you will expect that the hydrograph is quite peaked one. Okay. So and covers longer time period, flood warning time for downstream residents is longer. So this, if you are having higher order basins, then you are to some extent you have an time to give or issue an warning, but in terms of the lower order stream or the basin areas, it will be you will be having less time to issue the warnings. Okay. So now you can use this information to talk about the that which area will have quicker flood and which areas will have the floods which will be slightly delayed. Okay. And that you can issue the warnings and all that. So this is what is the beauty of using the drainage pattern and all that, and try to look at the stream orders and then extract the information. Okay. So, using the satellite data you can do this actually. So, I will stop here and we will continue in the next lecture with more information on this aspect, and also we will talk about, as I told in the previous lecture also, that we are going to do one more exercise, that is on the morphometric analysis. Okay. So, this is one of the part of the morphometric analysis we will be doing. So, with this I will stop here. Thank you so much.